let's say that you have data for this period of time, and this is your arbitrary time zero, and this is your end of data. What you can do is that you can use this data to perform some out-of-sample forecast. And then you would estimate your model using parts of the data, and you would then forecast the next step here. So if this is daily data, then you would use all these dates, or the data for all these dates, to forecast this date over here. Okay, so you estimate the model, and then you forecast the next step. And this is called a pseudo forecast because you kind of know this this data, but the model does not. Okay, so what you can do is that this forecast can be compared to the actual value in your data. So this is quite neat, because then you can test the forecast performance of your model. But you want the forecast of all these dates in the out-of-sample data to get more forecasts, so you can actually say something about your model's forecasting performance. So the steps that we go through to make these forecasts is that you divide the sample data. So the sample is here. So this is capital T, this is 0. And you divide the data into a sample or the training set and a test set. Okay, so this is P number of days in the test set. And you do not have to partition the data in this way. You can also partition the data such that at random you have like a certain amount of the data in the test set, or no, the training set where you train your model, and then you have in your some other days or in the auto-sample set, you have some random days from 0 to t. But for our purposes, we are going to look at this organization, which is incredibly common, and we are then estimating the model. So the step 1 is to partition the data into a training set and the test set, and you estimate the model using all these observations, and then you would perform a forecast of the next step. And then this forecast is y tilde s plus 1 given information in S. And you have the forecast error, which is u tilde s plus 1, which is equal to the actual value minus the forecast. So this gives you a forecast error, and what you do now is that you increase the S, or the test, the training set, to include the next day. So now this is the data which you use to train your model, which is just to run your regression, okay, and get coefficients. You use these coefficients and the data on the explanatory variables for this period, and you get another forecast, and you compare this forecast with the actual value for this second forecast date. So now you have two forecasts, and you have two forecast errors, and you just re-estimate your model using all the data up until now and make another forecast, the third forecast. And you get a third forecast error when you compare that forecast to the actual value. And when you have done this for the p days of the auto-sample partition of the data, then you can check whether or not the forecasts are the forecast errors are biased, or you can check the root mean square error of the forecast errors. And this means that you can get a sense of the performance of your model. So a model should have forecast errors which are unbiased and with a low root mean squared error, and or forecast error. And so these pseudo auto-sample forecasts, you can just gather them and calculate this bias or the root mean squared error. And what's good about this use of auto-sample forecast is that the auto-sample forecasts incorporates the forecast error of the model, the population model, plus the estimation error of your model. So you can compare different models with forecast errors to check which model would provide a better forecast auto-sample.